This is a recording of the webinar hosted on 2D survey to 3D visualization. As we can receive data from various sources, I have selected an exercise where I'm going to insert a picture to create the 3D tin model. We will complete the following steps to create our model. First, we'll insert our picture, we'll trace our existing contours, create the 3D points, generate the model and cut it aside. We will perform the volume calculation, generate sections, and even drape a picture onto our DTM and load a structure on top of it. We will start by loading a picture and then tracing the contours. You will notice that I've already loaded a picture, and I did that by selecting File under the Applications menu and Insert Picture under Commands. I will use the polyline command to trace the contours, but because I want a structured drawing, I will select my active layer that I want to place my contours on. From the Commands menu, I will select Lines, and under Lines I will select Polyline. Let's zoom in a bit closer. You'll notice now I will trace these contours by clicking on them. When I get to the end, I right click and select Option End. By pressing the spacebar, Caddie will repeat the previous command, which is the polyline, and I just follow and trace the contours for the second one. I will continue and create this for the whole drawing. A great feature of using a polyline is if I want to tweak the polyline, if I did not click accurately, I can just select the polyline, select the node point, and I can just move it closer to the line. You will also notice that on the contours of the picture I've got text which represents the height of each contour. So I will go now to the text and enter text and place the height relevant to each contour next to the contour line. The first one is 13. I select text, enter, indicate the position, and I place the text. Now I will enter the second one, which is 12.5 meters, and I place it. The third one is 12 meters, and so on until the whole drawing is completed. Our next step is to transform our contour lines to the heights as entered. To save time, you will notice that I've already completed all the contours and the relevant text. I have zoomed out so you can see the whole drawing where I've completed all the contours. Just to confirm where the lines are lying on the UCS, I'm going to switch off the picture and orbit the drawing so that you can see where the lines are sitting at the moment on the UCS in a flat 2D plane. If I switch my view to a perfect front view, you'll notice there's one line. If I orbit it slightly, it's all lying on a flat 2D plane. To transform the contours, I will select DTM. Under the Applications menu and in the Commands, select 2D to 3D translation, and I'm going to select Auto as an option. With Auto, Caddie will run through the whole drawing and automatically translating the contours. I will select Scope and select OK. In the command line, Caddie prompts for the radius to do the search. What this means, it will run through the drawing through each contour looking for text at the given radius and then translate the contour with that height for the text it picked up. If I've entered 0.5, press enter, and you'll notice my contours have changed color to show me and indicate that it has translated it. I'm going to select Constraint Orbit, and I will orbit the drawing to show you that the 2D contours we had earlier has now been converted to 3D points. I will select Top View, and now we'll go to the next step by creating the 3D points from our contours. The first thing I want to do before I continue is to select my active layer for my 3D points. Let's continue to create the points. From the Commands menu, I will select Contour Points to draw and export points from contours. From the dialog box, I will select Scope as my selection mode. I'm going to select Draw the Points, and should I want to export my contours to file, I will select this option. I will not use it for now. My minimum distance is 0.5 meters. Okay, it's picked up. I've got 59 contours, and it will create an X amount of points. Do I want to continue? I will select yes, and my points are generated. The final step in creating the tin model is to do the triangulation. Again, as I want my drawing to be structured, I will select an active layer for the DTM or for the tin model to be generated on. From the DTM menu, I will select triangulation command, and in the command line, Caddie prompts me to indicate the extents of the DTM to be created. So I'll indicate the bottom left and top right hand corner, and you'll notice our tin or DTM has been created. Before we orbit to have a look at the site, I will switch off my points from the top menu, and I will switch my render mode to Phong Shaded. Let's orbit around and you can see what has been generated. I will set it back into top view. Now before I cut our site into our DTM, I'm going to make a copy of the DTM, which will enable us to do a volume calculation between the two tin models or the two digital terrain models. I will select the DTM, right click copy, indicate my first point and the second point, and I have a duplicate tin model. Now we can continue by cutting our site into our tin model. In order to save time, I have already drawn the site that we want to cut into our tin model and have placed it on another layer that I will now display. I am also going to change my render mode to wireframe so you can see the site in the green polyline underneath my tin model. If I know the height where I want to cut my site into my tin model, I can select the option that says section. But if I want Caddie to calculate the height for me, in order to minimize the cut and fill, I can select calculate fill, and from the dialog box I have a few options. First, I can select the shrinkage factor, where I can select the type of swirl that we have on our site. Next, the number of passes, which will control the accuracy of my calculation. When I increase that, it will be more accurate, but it will take longer. Maximum acceptable volume difference, and in this example I have set it to 1 cubic meter. I will select OK, and I will select endpoint snap mode and just go around my site and click on the corner points. I will zoom into the drawing for more accuracy, and I'll start in a clockwise direction and continue the points. To complete, I will select right click and option end. Caddie completes the calculation and comes up with the information box stating the height as well as the volume difference of 0.77 cubic meters. Caddie has also calculated the height of just over 10 meters to cut my site in, and it asks me if I want to cut the area into the site. I will select yes. I will now change my render mode to Phong Shaded and orbit the drawing so we can have a look at what has happened. Notice the area that has been cut and filled to level our site. I mentioned earlier that we're going to do the volume difference calculation. That is the reason I copied the initial DTM. Now let's do that calculation. I will zoom out so that we can have a good look at both the tin models. From the commands menu, I will select volume difference function. Caddie prompts me in the command line, first indicate the first tin model and then the second tin model. And now I will indicate the second tin model. Notice in the command line, Caddie prompts me with the difference between the two volumes. Please note the top of my Caddie drawing area, I've got a drawing loaded which has got my structure on there. I'm going to take my site and place it onto my new drawing. I don't want my lines, so I will deselect my lines, and I'm going to select my tin model. Right click and I will select copy to clipboard. I'm going to indicate the origin point, and from here on I will switch to my structural drawing where my house is on, and I'm going to paste it from the clipboard. Select my architectural drawing and I will select right click, paste from clipboard. Caddie will now prompt me where to indicate it, and as that layer has been switched off, I'm going to layer display and just switch that layer back on. Notice in my drawing background, As soon as I switch the visibility of this layer on, my tin model is displayed. I will switch the render mode to Fong Shaded, and I will orbit so slightly just to see how to move the house. I will select my house and then I'll start the translation. Very important, my snap mode will be set to 3D. So I will select it, set my snap mode to 3D, and I'm going to zoom closer, right click, move, and I will set to endpoint snap mode, indicating the corner of the structure, and you will notice the drag on my cursor. Caddie asks me for the new position. I'm going to select right click and rotate it with 50 degrees. Select OK, let's zoom closer, and I will indicate this corner of the site and place my structure on my site. By pressing R on the keyboard, I will regen my drawing. Now let's orbit and move around the structure so you can see the site and the house on top of my site. I will change my view to top view, and let's create some sections through our site and building. Now I will select my active layer, layer number 10, for sections. I am going to demonstrate both the sections through the site using the DTM module as well as the AEC module. I'm going to place construction lines onto my drawing as reference lines to create my section lines. The first sections I will demonstrate will be using the DTM module. So I'll just zoom a bit to the side and I'm going to select section. In the command line, Caddie prompts now to indicate the section profile on plan. I'm going to use the construction lines as reference lines and indicate the first and the second point. Select option end. The first option is to write the section heights. Here I will indicate the height and the scale that I want to use the text. I can also include a reference level and enter the height that I want the reference level for. I have scaled my vertical scale with a factor of 2, and I want Caddie to draw the section lines. When I select OK, you will notice the profile of the section on my cursor and I can place it on my drawing. Now I'll do the vertical one. I'll select the first point on the construction line, the second point, right click option end. I'm going to set the current units and I will place the section. Now to make it a bit more interesting, let's continue and create sections using the AEC module. I will pan the drawing to the side in order to give us some space to place the sections. Under applications, I will select the AEC module and I will select plan section elevation, and I'm going to select vertical section. From here I will select quick section, and Caddie will prompt me to indicate the profile. Selecting endpoint snap mode, I'm going to indicate the exact same section lines as we used with the DTM. First point, second point, option end. Notice the arrow, and Caddie will prompt me which direction to look at. I am going to select the top side and I will place the section. By pressing the spacebar, I will repeat the previous command, select quick section, first point, second point, right click, option end, and Caddie will ask me which direction. I'm going to indicate to the right, and I will then place the section. The last step that I want to show you is to place our picture, to drape it on top of our DTM. As our tin model consists of a lot of triangles, I need to convert this to one polyface mesh. Let's select redraw and continue. After creating the polyface mesh, I will disable the triangles and then drape the picture. So I will select another active layer to place the polyface mesh on. Because we have worked with a structured drawing using our layers, I am going to disable or switch the visibility of all the other information off. So I will just switch on the two layers that I need for the moment, one with the DTM on and the active one to create the polyface mesh onto. I will select from the DTM module, select my DTM under applications, and under commands I will select conversion to one polyface mesh. I will draw a rectangle over my tin model, and Caddie will start with the process to create a polyface mesh from our triangles. After completion of this process, I will switch the visibility of my tin model off and only see the polyface mesh. When I now select my polyface mesh, you'll notice it will consist of one object. I will now load the picture that I want to drop on top of my model. Under my applications menu, select Caddie. I will select the files application and insert picture under commands. I will select my picture that I want to load, and I will indicate the position. Notice the size of it is completely out of scale compared to my model. Under the DTM module, I will now select DTM under applications and the commands, the drag command. In the command line, Caddie asks me for the two extents, first of the picture and the second of my model. So I'll indicate the first point on my picture, I'll zoom in for accuracy, and then the second point. Now I'll indicate the corresponding 2 points of my polyface mesh by selecting endpoint and indicate the first point, and I'll indicate the second point. When I start to orbit, you'll notice that my picture has been dropped on top of my site. If you have a Google image, you can even load a Google image on top of your polyface mesh. Now let's switch the layers back on for our structure, and let's do a walk around our site. Under the 3D view command, I have created a path that I want to walk around my site. The first thing to do is to switch to perspective mode, and then I'll do a walk around and demonstrate that. In conclusion, we've created a fairly complex drawing from a mere picture. We inserted the picture, we traced the contours, we entered the text for the heights for those contours, and then Caddie traced those contours for us by transforming them to the height positions of the text placed next to them. Then we asked Caddie to convert those contours to 3D points, and we convert those 3D points into a tin model by the Delaunay triangulation algorithm. From there we took our site data and we asked Caddie to calculate the height for the least cut and fill, and to level our site in to place our house on top of our site. As an added bonus, let's quickly generate our new contours. To do that, I will switch off the visibility of the polyface mesh, and I think just for complexity, let's switch off the house. That layer is switched off, only the DTM for my tin model, select OK. Under DTM I will select contours, and I will indicate the first and the second point of my site. These are the values that I can enter, minimum, maximum, contour values, etc. The layers, I will select OK. And Caddie will start to generate the contours. I will now go and switch the DTM off, and there are my contours.